What would happen if gravity disappeared for just 1 second across the entire universe? In this video, we'll answer that question. Imagine you're sitting in your room holding a cup of tea and enjoying it. But in the blink of an eye, the immortal force that keeps everything in order decides to leave us on our own for a second. What do you think would happen to you, your house, the Earth, or even the entire solar system? Gravity is like the secret glue of the universe, a force that keeps the planets spinning around the sun. The reason why we don't float in space and our tea stays in the cup is because of gravity. If gravity stopped working even for a moment, everything around us would start floating. The immediate effects would be unbelievable.
But here's the main point. This doesn't just affect us and the cup in our hands. The entire Earth, from its surface to its core, the whole solar system, and even the entire universe experience a moment of complete weightlessness.
Let's start with the Earth itself. Gravity pulls everything with a force of about 9.8 meters per second squared towards its center. Because of this force, everything on Earth, including the oceans, the ground, the crust, us humans, and everything else, stays firmly attached to the planet. If this force were suddenly removed, we would all begin to accelerate upward at exactly the same rate of 9.8 meters per second squared.
We can calculate the exact displacement of any object using the equation of motion under uniform acceleration. This means that during 1 second of gravity being inactive, the ocean waters move approximately 4.9 meters according to this formula. Although this distance may seem insignificant, on the scale of the oceans, it is a very large number and has catastrophic effects.
Now imagine gravity returns. All the ocean waters suddenly fall toward the Earth with an acceleration of 9.8 meters per second squared. Considering the 4.9 meter height they had reached, we can calculate their impact speed on the ground using the equation of motion. This means the ocean waters hit the Earth's surface at a speed of approximately 35 kilometers per hour. The result of this collision could be massive tsunamis, with waves towering over hundreds of meters high. These waves could wipe out countless coastal cities. As you know, the Earth is made up of 4 main layers and an atmosphere. The atmosphere, the crust, the mantle, the outer and inner core. Due to the weightlessness caused by the temporary loss of gravity, the crust and atmosphere of Earth are heavily affected. Due to the weightlessness caused by the temporary loss of gravity, the crust and atmosphere of Earth are heavily affected. Let's start with the crust. For a short moment, Earth's crust would experience a state of zero gravity. Without the downward pull of gravity, the crust, which is already under immense internal pressure, would likely begin to partially detach from the mantle and core. After gravity is turned off, due to internal pressure and the absence of gravity, the Earth's crust moves about 2 to 5 centimeters. A small number, isn't it? But even this small number, meaning if it moves only 5 centimeters, according to the previous formula, it returns to its place at a speed of 1 meter per second. A massive collision. This number may seem very small, but considering the mass of the Earth's crust, even this small displacement can trigger earthquakes up to 10 on the Richter scale worldwide. And that's not all. Many volcanoes could suddenly become active around the world. And now, Jeff. In the absence of gravity, the Earth's Jeff begins to expand and disperse upward. Air molecules move away from the Earth's surface because there is practically no force holding them downward. During 1 second, the molecules move upward due to their thermal energy. Considering the average thermal speed of oxygen molecules, which is about 500 meters per second, it can be estimated that the outer molecules of Jeff move approximately 500 meters outward, and consequently, the lower layers also rise several hundred meters. Now imagine gravity returns. Jeff, which has expanded 500 meters, begins to be pushed toward the Earth's surface. This rapid compression causes sudden changes in air pressure at the Earth's surface. It also generates winds as powerful as Hollywood-style artificial storms, but this time they are real. These storms form worldwide and bring terrifying floods with them, and this is just about the Earth itself. Now think a little bigger. What do we do? Imagine what would happen to the solar system. All the planets in the solar system orbit the sun, and their motion depends on its gravitational force. They are all moving along their paths, and if gravity in the entire universe suddenly stops for a moment, they would all deviate from their orbits. Although this interruption is momentary, its effect on a cosmic scale is enormous. Our Earth might return to orbit around the sun after that moment, but it will no longer follow its original orbit.
Even a small change in the orbit can lead to long-term alterations in seasons and weather patterns on Earth. And if we extend our view a few years into the future, the likelihood of multiple galaxies, stars, and planets colliding is very high. Imagine several magnets placed close together without touching each other. Now apply an external force to the surface holding these magnets. Boom! They all collide with each other.
This is exactly what would happen to the universe. However, there is one major difference. The universe is enormous, and if we consider the Earth as the center of this shutdown, it would take time for this 1-second interruption to reach other solar systems. It's like shaking a large blanket. The wave takes time to travel from one end to the other. It could take millions of light years for the far end of the universe to feel this 1-second shutdown wave.
See what 1 second of shutdown can do to the entire world? Now, do you think we would survive these catastrophes? If we manage to survive the tsunamis, consecutive earthquakes, massive storms, and the extreme pressure of the atmosphere on the Earth's surface, there might be a chance that, with the few bruises from hitting the ground, we could record this memory and share it with future generations.
Friends, thank you for staying with me until the end. Write your thoughts in the comments so we can analyze this topic together. Don't forget to subscribe to the channel. See you soon.